So I do have the pleasure to introduce this session today. And so we will explore how high-performance facades and sustainable materials enhance holistic health and well-being in the built environment. This session examines the intersection of building envelope engineering and well-being conscious strategies, focusing on the use of healthy materials, improve occupant comfort, and ethical supply chain. Discover how integrating these elements can foster a more sustainable and health-focused approach to building envelope design. Simulated real-world scenarios will be presented, and the discussion will focus on how different facade designs and material selections impact envelope performance, people, and climate. So before I introduce today's speakers, I would like to just please remind you to silence your cell phones. And after the seminar, if you could please take the opportunity to explore the trade show floor. There's over 135 manufacturers, distributors, and suppliers with products and services that could considerably improve your business or your next project. So as mentioned, I do have the pleasure of introducing our lovely panelists today. So we have Stephanie Fargas, who's Associate Sustainable Materials Specialist at DIALOG. Stephanie is an Associate and Sustainable Materials Specialist who's emerged as a leader in material transparency, bringing extensive experience in material product research and preparation of specifications for projects across North America. In addition to being a registered specification writer, she provides expertise in embodied carbon, circularity, material health, and social equity through the supply chain. She's dedicated to sustainability, guiding material transparency for projects seeking LEED, WELL, and Envision certifications, and notably led the specification development of Canada's first Living Building Challenge project. With a creative approach, Stephanie excels at translating design intent into clear, precise specifications while mentoring staff and facilitating communications among project participants, as well as your work at helping us with CLF Alberta, which if you'd like to learn more about that, please come and see us. We also have Andrew Brassington, Technical Sales Manager of Owens Corning Canada. So with over 20 years of experience in the building construction manufacturing industry, Andrew has built a distinguished career defined by technical expertise and leadership. He's held key roles in several leading manufacturers, consistently driving innovation and performance. He's a Technical Sales Manager for Owens Corning in Western Canada. Andrew is also actively involved in shaping the future of the industry. He sits on the National Board of Directors for Construction Specification Canada and contributes to technical committees for both the Canadian Home Builders Association's Net Zero Council and Build Edmonton Metro. A trusted resource within the building design community, Andrew regularly shares his knowledge with architects, contractors, and builders, and his presentations offer valuable insights into critical building envelope topics, including waterproofing, air barriers, and insulation, empowering professionals to make informed decisions that enhance building performance and durability. So with that, I'm going to hand it over to Stephanie and Andrew, and thanks again for attending our session.
All right, hello everybody. Man, I was trying to make that bio long enough so that we wouldn't have to present, but here we go. So I'm Andrew. This is Stephanie. I don't know, some of you know us, some of you don't, but if you don't know, now you know. Okay, wait, just checking the vibe in the room. I can see, need to wake you guys up a little bit, but here we go. I'm gonna try my best. So here's the lovely agenda that we have today. We're gonna do a quick introduction on some key terms regarding our presentation, then followed by the current economic and industry drivers, then some design considerations, some material considerations, and then finally we're going to talk about what the future might look like in the future state portion. So let's talk introduction. So you might have seen these terms before: operational carbon and embodied carbon. So just to give you some definitions on that, so operational carbon is basically the energy that the building uses when it's in operation. Surprise, surprise. The embodied carbon is pretty much everything else. So from getting the raw materials to the manufacturer, the manufacturing process, the delivery and installation on site, as well as maintenance, repair, and then finally deconstruction and waste disposal. So now you kind of know the differences between those two. Now we also have what we call life cycle assessment, or LCA is what the industry is commonly using. The LCA document is a product life cycle in either cradle to gate. So cradle to gate will be A1 to A3, so it just keeps in mind the manufacturing process of the product. And then there's also cradle to grave, which goes from the manufacturing process all the way to the end of life. Right, so there's that, and then finally there's also cradle to cradle, which if you start off being able to recycle materials and reuse those materials, that would be considered cradle to cradle. With the life cycle assessment, they've conducted to determine the environmental impact of either the product or buildings. There's 6 main areas or impact categories that we look at. So you can see we have global warming potential, which is a no-brainer. Depletion of stratospheric ozone layer, yeah, we definitely don't want that to happen. Acidification, so acid rain, we know how much that impacts the environment. Eutrophication, which is a measure that uses the potential contribution to the nutrient runoff and damaging aquatic systems. The formation of tropospheric ozone, right? So that's now trapping ozone in, or providing a layer. And then finally, depletion of non-renewable energy resources, right? That's the areas that we look at with the life cycle assessment. So when it comes to EPDs, or environmental product declarations, these are important documents that we're going to see a lot more. I know as a salesperson before, we used to sell a lot on technical data sheets. Now I think the future is going to be with EPDs, right? So the way EPDs work is, first you have to establish a product category rule so that all the products in that category are judged in the same form. Not every product has this yet, but I know they're all working on that, right? And then from the product category rule, we use a life cycle assessment to determine the impact of the products on the environment. And once we've collected all that data, we're able to produce an EPD. And then that EPD goes to a third party to be validated. And then finally, it's publicized. Now, EPDs are actually very expensive documents for manufacturers to produce, so a lot of times you'll start to see just industry average EPDs, sorry. That's, some manufacturers will go to that, some products will be there if their industry especially isn't that large, but the manufacturers that invest in doing their own EPDs really give you an accurate guide on what products you're installing and give you accurate information on your material choices. For example, Owens Corning, coincidentally I work for them. They have one as well, and it's just to show you an example, but there's a lot of manufacturers out there that do have EPDs, so I encourage you when you're doing a material selection, take a look at that document as well, not just the technical data sheet. Now, there's what we call a common material framework, and these are basically language that we're trying to make the industry adopt so that they can have like the same language across the board. So we're all saying the same thing. So there's ecosystem health, which works with the environment, and we want to make sure that we're using products that don't damage the environment. We have social health and equity, and that relates to human rights, right? We don't want to use materials that are maybe done or produced in a non-ethical way. Then we have circular economy, so if we can use products that can be reused again in the future, we like to use those as well too. Then there's climate health, so of course we want to make sure the climate isn't impacted, and let's not forget us in the room, right? Human health. We want to make sure we're not impacted by the products that we pick. And then take a look at this slide. So when Stephanie and I were putting this presentation together, I was like, wow, Dialog's got some really fancy dividers for their presentation. And I'm like, that's pretty cool. And then she's like, well, no, that's not what this is. So this actually shows, it's basically a stripe that represents the average temperature from 1960 all the way to 2020s. So, and you can see the blue marks represent how it was lower than the average temperature versus, as you see, as we get into the 2000s and above, it starts to get more red, so it's getting higher. So we can see we were trending in the wrong direction, and that's why talking about these subjects and carbon and these things are really important to advancing the industry and also protecting the environment. I'm going to pass it off to Stephanie now.
So as Andrew had mentioned, materials and the ability to really have an impact on climate change is really critical. We're at that moment where if we don't do anything, we really have to hit net zero by 2050 to hit some of the Paris Agreement guidelines, as well as you're gonna start to see that the biggest impact all of us can do on decarbonization or reducing the impact of our projects is really highlighting and emphasizing sustainable materials. So I like to put this graph in to kind of demonstrate that on a personal level, you can make changes, but really it comes down to the materials that we use on our project. So I kind of put some of my personal life choices on here. Actually, sorry, a life choice for Andrew. So this was like embodied carbon if we were to fly from Edmonton to Newfoundland. It's nothing compared to one project that I worked on, which was a recreation center here in Calgary. Just the structural steel in this addition that we did is that, and we tried our best to identify low carbon steel, identify opportunities for repurposing, but you'll see that like materials really do have the biggest impact. Even if you went vegan, it doesn't come close to just one material on one project. Going a little bit more in depth into the social equity, materials are one of the biggest contributors right now to forced labor, and forced labor not only includes like child labor, individuals that are being held against their will, but also the incarceration issue that we have in North America. It was shocking to me to find out that a lot of the manufacturers that we commonly specify use incarcerated individuals that aren't being treated in an equitable way, and that also are in situations where you don't really have a right to fair pay or fair situation. And this is starting to come down into some of the manufacturing plants. Like for example, a local steel manufacturer in Canada is one of the only manufacturers globally that has a social equity certification for their steel. So I thought that was a really good kudos for Canada. And it really ties into the fact that as of 2023, Canada does have a law of anything entering into Canada, regardless of it being a construction material or not. There is laws against forced labor. So with like the greening government strategy and whatnot that the federal government is pushing, that's really trying to emphasize that we really need to get better in how we evaluate materials and how we import materials. And so from a North American perspective, I'm gonna kind of provide the context into the current situation politically in North America as well as globally. So despite the political regime in the US, there are still states that are pushing towards decarbonization and that are developing policies that a lot of governments, both at the city level or municipal, provincial, and as well as the federal government is starting to adopt in how we procure products in Canada. Some helpful resources if you want to learn a little bit more about social equity is Design for Freedom. They're a non-for-profit focused on removing forced labor through the supply chain. Responsible Steel is that certificate I had mentioned that a Canadian producer has. As well as if you're interested in knowing common materials and what the industry consensus is for embodied carbon, I highly recommend looking at the Carbon Leadership Forum North American Baselines that just got recently published. And from what started as a North American collaboration where I was fortunate to be one of the first and only Canadian representatives on this with Mindful Materials, was our goal as a collective was to re-envision what is the future of materials, how do we democratize information and make it accessible to everyone at an equitable access point, and how do we upskill individuals that this is new to them, it might require rethinking from a manufacturing perspective. So we have representation from owners, big tech, non-for-profits, certification bodies, as well as consultants and manufacturers and the construction side. And you'll get the sneak preview of this. It'll be announced at Greenbuild, but a huge accomplishment for the work that we've been doing is the Common Materials Framework that Andrew had introduced first. This is now being recognized globally, so all the different rating systems have now adopted this in an effort to be agnostic and to make sure that manufacturers aren't having to pay for additional certifications that just don't make sense anymore, as well as with the supply chain being global, this adoption is now being put into place with England, Australia, as well as we're starting to expand into different marketplaces. So I thought that's a huge step for really moving towards a sustainable future. And from a Canadian perspective, like I mentioned, the greening government strategy that came in a few years ago, the focus on this was really how do we decarbonize the Canadian built environment by prioritizing heavy embodied carbon materials such as carbon and steel as a primary focus. And to complement that, how across Canada can we get a standard approach of conducting life cycle assessments? So those that are interested in learning a little bit more, I recommend checking out the National Research Council's guide on how to conduct a whole building life cycle assessment. Canada is also leading the way in decarbonization. We're one of the only nations that have our own independent embodied carbon certification through the Canadian Green Building Council, and that's being adopted in LEED version 5. And from a municipal level, this diagram kind of shows where different cities, as well as where is the federal government's approach as it relates to decarbonization. And so depending on where you are in Canada, the reporting is slightly different, or the priorities, you'll have to approach your project slightly different of whether your emphasis is on operational carbon or if it's whole life carbon. And from a consultant's perspective, regardless of what political party is in power, there's been a lot of movement from the consultant side as well as the owners of really owning the fact that the built environment has a huge opportunity to meet our embodied and climate goals. So some of the different commitments out there that are applicable to both Canada and the US is AI 2030. That's for tracking your energy, but there is also an option for tracking embodied carbon. MEP 2040 is focused on the mechanical and electrical engineering of how to remove and track embodied carbon in refrigerants and some of their components. SE 2050 is focused on structural engineers, and then the AIA Materials Pledge is focused on the architecture and interior side. And then from a building code perspective, you're gonna start to see that legislation is gonna be put in by 2025 and 2030. There's discussions right now on how do we approach embodied carbon reductions from a national perspective, understanding that each province has a different energy intensity grid, and how do you make it fair for tracking based off where your project is. And so I'm gonna go into some design considerations. So some easy wins that you can have is really introduce it early. The design really has the biggest influence. So being very critical of what materials as well as how you use those materials, work with your engineer to figure out placement of structural support to really reduce the amount required and to also meet your design service life of your building. The ones further down the list are harder for a consultant to actually have an influence on, especially in Alberta where our grid is considered a dirty grid. We don't have that luxury like other provinces do where we can quickly electrify the building at not much of a cost. And then from a material production side, we don't have the greatest influence on sourcing only true low carbon materials or materials that can achieve different sustainability attributes like carbon sequestration. That's currently in development with like some of the concrete work that is happening in Edmonton. There's a lot of investment happening in capturing the carbon that comes off of heavy emitters from oil and gas and putting it back into the manufacturing of cement. And like I mentioned before, the earlier you start to have discussions on embodied carbon is a way to reduce the cost and ability to have that actually achieved on your project. The later you wait in the timeline of a project, the less likely you are to achieve that, as well as considering just the volatility of the supply chain. And then from conducting a life cycle assessment, this is just our recommendation on when best to involve the consultants as well as the client, and what different deliverables you can implement on your project to really achieve significant embodied carbon reductions. I always recommend, regardless of your procurement or contract method, have that information as early in schematic design and have it priced, because a lot of the materials aren't easy to get low carbon options, and then with the current situation that we're in with tariffs and everything, it just adds that added layer to it. Another option I would recommend is like potentially having separate prices in your bid so you can actually see what the cost differential is. And then if you do have the option, use less materials. So I think towards the future, we're gonna start to do more of adaptive reuse on our projects. And then just here is another high level kind of workflow that we recommend of having constant life cycle assessments done at different phases of the project to really evaluate your current design, as well as to conduct life cycle cost assessments to see if your embodied carbon reductions also have cost considerations. I'll pass it off to Andrew.
Thanks, Stephanie. Raise of hands, show of hands. Who likes carbon? Okay, good. I was hoping that no one else would bring their hand up. So life cycle assessments, we're looking at this, and we start to look at calculating the total embodied carbon, either for a total wall assembly or just total on the project as a whole. So it's similar to calculating your material. So if you look at what's on the screen there, so if you have material quantity versus cost coefficient equals the material cost per unit, right? So if we had 100 of something and it costs $100, you can get a cost from there. And then same thing when it comes to material quantity versus a carbon coefficient, you get the total embodied carbon. So let's go to the next slide here. So when we start looking at total embodied carbon emissions, there's sometimes in walls especially, you have multiple products in there. So you need to calculate them all. You need to take them all into consideration to get that total embodied carbon number. So then once you've done all that math, because for everybody who likes math out there, you got all that math, you got the total embodied carbon, then you can start working on the average for the embodied carbon intensity, right? Because that's something we want to look at. You take the total embodied carbon, you divide it by either the square footage of the building, or it could be the specific assembly or the specific type of product that you're using to determine your embodied carbon intensity, right? And it's not a calculation has been normally used, but it's something that we're starting to use more and starting to look at more because we're really starting to take this into consideration. So now that you know that piece, while you're trying to do all those calculations, there's other stuff you have to take into consideration, especially in the walls when you're selecting your cladding attachment strategy. So what's the weight of the cladding, right? What's the environment? Is there heavy wind loads? Is there seismic? Is there, building orientation is a big one. I was just watching a presentation on the new arena, and because of some of the demands, they had to face certain areas a different way or certain ways, and that changes the way they have to design, right? Combustibility requirements. Are you building really close to something, or do you have space where you don't have to take as much of that into consideration, although combustibility is an important thing. Allowable wall thickness. You're putting up a new building downtown, but it's in between two old buildings, so you don't have a lot of space. Substrate. That's a huge one right there. What are you attaching to? Followed by labor market. You might love EIFS acrylic stucco. You're like, this is a beautiful finish. It's great, but you don't have the labor market for it because some of the people can't do it correctly. And then there's additional performance criteria. And you're like, what? What's an additional performance criteria? The building code, right? So they throw that in there too, right? So you got to think of all those things, but you still got to make sure you're hitting the building code as well, right? And most of the provinces in 2024 had adopted the 2020 building code. I know it's a long gap in between there, or some way, shape, or form. I think BC, they call it the BC Step Code. In Ontario, it's SB 12. Everywhere else is pretty much the National Building Code with the province's version, right? But here's an example of what's changed from 2015 to 2020. So we see before we used to look at just opaque assemblies. So we moved from what we call a nominal wall. So we used to put, an R22 bat in the wall. You call that an R22 wall, you dust your hands, you walk away. And then we realized thermal bridging is a thing, right? wood studs or steel studs are not R22, so we had to calculate that, and that's what happened in 2015. So now we're calculating an effective R value, so taking into consideration the studs in the wall. And then finally, we moved to 2020, where we're like, okay, well, now we got the studs, but what about all the other junctions? The ceiling, the floor, around the windows, all those areas. Those are areas where energy can leak out. So now we have to take those things into consideration as well. So showing the similar slide that Stephanie had showed. So step one was to adopt 2020 code, and that increased the energy efficiency of new construction. So we started to do that. We're like, we got to change. We got to start now. We got to start building the right way. So we adopted that. That was step one. And then step two, which is coming out December 2025, they're probably going to wait till the 31st at 11:59, but that's when the next code edition comes out, and that's going to have retrofits and operational carbon in it. Now, when it comes to this particular code, we're seeing a lot of provinces saying they're not necessarily going to adopt the code itself, do a full re-up. They're going to probably just add some addendums. They're going to take all the stuff, because some stuff hasn't changed as much, so they're going to take all the stuff that's changed and add as an addendum as opposed to redoing the code altogether. I'm pretty sure that's what's going to happen in Alberta. And then finally, in 2030, and like Stephanie had said, task groups are going on right now talking about GHG emissions and trying to figure out the way to scale this properly so that we have an accurate measurement, because, again, like Stephanie said, every province is different. You know, Manitoba is a pretty clean grid. And I was just at the CHBA national fall meetings, and they kept talking about how dirty Alberta's grid is. And I'm like, okay, it's getting better, and it's going to continue to get better every single time, but we can't be the butt of all the jokes, right? We're doing our best. And I think that's a good thing. We're very conscious of that, and I think we're making design choices towards that. So let's talk first operational carbon. What can we do to reduce that? Now, just so you guys know, we talked about this. Operational carbon is the carbon that's produced when the building's in operation. So NRC, they put together some studies, and this is some information that's available online to talk about where energy is used in buildings. So we can see by the charts, whether it's institutional or commercial or residential, we can see over 60% of energy in a building is from heating and cooling that building, right? So one of the things we have to do is we have to find a way to reduce that, and a big contributor to that is thermal bridging, right? Thermal bridging occurs when a component is relatively high thermal conductivity bypasses the thermal insulation, right? And like I was mentioning before, wood is not R22, where it's like R1 per inch. So we have to take that into consideration. So one of the solutions you can do to help that is to cover it up. Right? We wrap the house, put it like a big sweater on there. Now there's other solutions like that. We can talk about air tightness as well. That helps too, so I don't want to discount that, but as an insulation guy, I'm going to talk more on the insulation side. All right, so now we've seen this. We're like, oh, we'll cover it up. We now know we can reduce the energy that's used in the building, but not all exterior insulation strategies are created equal. So if we take a quick look at this cladding attachment performance chart, we can see, you know, we're going to do this with 5 inches of exterior insulation. We're going to call it all exterior insulation. We decided that, you know, we're going to use vertical girths. So hopefully no one here is designing with vertical girths anymore, because we can see when we use vertical girths, it's just an extension of the stud. So you're getting similar type of thermal bridging where you're only getting 50% effectiveness, or just over 50% effectiveness of that insulation on the exterior, right? You're almost better off just using, continuing to use cavity insulation at that point. But then, if you start to go horizontal, we can see a change now. So we can see that because we've disconnected the stud a little bit more, less touch points on that aspect, we've now increased the performance of our insulation. Then we said, well, let's do a cross gird, because that sounds like a great idea. And we're like, that worked out better because we continue to improve the insulation. But if some of you in the market know, we have other different systems. Like we have clip and rail systems, which clips, and then we have direct attachment systems, which uses long screws and strapping. So typically, in most situations, using a clip and rail system is going to increase your improvement, because with the clips, you have, again, less touch points, right? Wrong, because the spacing spacing decreased when we were using a lot of clips, we now actually reduced our effective R value because of the fact that the spacing was really tight. As we continue to take the spacing out, okay, that makes more sense. Now we're starting to, again, get more performance out of our insulation, more performance out of our wall, and then again, higher spacing, better performance. But I always caution about 36-inch spacing because a lot of times it's hard to do that because you have to talk to the clip manufacturer and make sure it's going to be able to hold the cladding weight, because as you get further out, usually the cladding can't be held as well, so you usually have to get a little tighter, and that's why you get those other tighter spaces. And then finally, if you're going to a direct fastening approach, you're getting a lot more effective. It's usually around 95% effectiveness for the insulation, and then calculating with all the other components there, you get almost a higher R value. You're getting up to R22, right? And that's with all the components in there, right? The drywall, etc. So you can see, just because you put exterior insulation on there, it doesn't mean the job's done. You got to take into consideration the strategy for sure. So when it comes to thermal envelope calculations, and sometimes these can be hard in trying to get the modeling done. So luckily, thermalenvelope.ca is a great website that you can use as a resource to go on, and this website will show you opaque walls, will show you junctions, floor, ceiling, roof. They'll have all those calculations in. They have a lot of examples from a lot of different manufacturers. And I mean, if you're around in a couple weeks, Alberta Building Envelope Council South, they're doing a presentation on November 6th, specifically on this particular website. And they talk about all the updates. If you've used it before, there's actually updates that have come out. I encourage you guys to take a look at that presentation and maybe even sign up. Okay, you've gone through that part. Now I got a skill testing question for you right here. I hope you guys were listening, writing down notes. Why do we have exterior insulation? Is it A, because green or pink insulation look cool or look great on exterior walls? B, thicker walls are cool? C, windows look better with insulation around them? D, reduces thermal bridging? Or E, all the above? Who's got an answer? Come on. You can't answer, you're part of the group. Anybody here? Come on. Who said D? Put your hand up if you had D. I'm trying to see who was the first one. I think it was you in the back. And
Oh, nice.
there we go. Okay, man. My arm, I just got a lot of power in there. Okay, so you were right. Reduces thermal bridging. Okay, so now the question starts to ask, are we going to go all exterior walls, or are we going to go with a split or a hybrid wall situation? You know, because there's different advantages and disadvantages to both. Because if we think about an all exterior wall, we're like, okay, we got all our control layers all on the exterior. Everything's on the outside. We see a lot of commercial construction go like this. It's one of those ways where like we've taken care of everything. We're good. It's all on the outside. We don't have to worry about that. Then there's the hybrid wall. Well, the hybrid wall makes you have to take into consideration the cavity insulation as well as the exterior insulation. So a little bit more of a detail, but it's all about the details. Both systems work well. It's just a matter of as long as they're detailed correctly, right? As long as we're making sure we do the right thing. So you can see when you compare them both when it comes to effective value, so say we use 5 inches of mineral wool with cavity insulation versus 8 inches of mineral wool, because that's what the example I'm going to use right here. Both of them have the same clear field number, and both of them have the same overall performance, right? So we can see, in a nutshell, from a thermal performance perspective, they look like they're going to perform well. But there's certain advantages to going towards, say, a hybrid one versus an all-exterior insulation, and I'm going to show you why. And it starts with the embodied carbon piece. So we know what embodied carbon is. It's everything but the operations, right? So before I get into the embodied carbon piece, one area where you can find that information is, like I said, through EPD. So product transparency is important, right? Making sure EPDs, you read them. And I mentioned earlier, there's industry ones, then there's manufacturer product specific ones, and then if manufacturers really want to get into it, they can go manufacturer product plant specific, right? So then they can really provide a lot of information in regards to the product getting to your specific sites. Product transparency summaries are important. Health product declarations are important as well too, and just be aware of greenwashing, right? We talked earlier about the product category rule. We want to make sure that when we're evaluating that products, we all evaluate them the same way. So let's talk about the impact of insulation on embodied carbon, right? So there's a bunch of different ones, and I don't expect you to see this close, so I'm going to bring this a little closer. So this is a study done by the city of Nelson. They put together a material carbon emissions guide. So they took all the industry EPDs for all the installations. They did it for other materials. I believe they've done it for concrete, they've done it for steel, they've done a couple of them, so I encourage you to check out that guide. So within that guide, they go through different types of insulation. So looking at the exterior insulation, so rigid boards, right? We can see when it looks like XPS is one of the higher ones up there when it comes to embodied carbon, right? Then we see mineral wool in this, and again, these are industry averages, so some manufacturers can perform much better than this, and then some perform worse. And then finally, you look at potentially carbon sequestering products. And if you haven't heard that word before, these are products that are given a negative number because of the fact that they absorb carbon before their production, right? So wood fiber board is an example of that, right? And then we have wall cavity insulation. So again, going through some of the mainstream ones, we have mineral wool bats. You can see we have wood fiber, or wool bats, and then we see fiberglass bats in the bottom. And again, there's other carbon sequestering types of insulations as well too that can continue to reduce the embodied carbon in your wall assembly. I'm going to talk more about three of the ones that I'm more familiar with. I'm going to talk about XPS, I'm going to talk about mineral wool, and I'm going to talk about fiberglass, because these are the more common ones that we are seeing out in the industry today. So we took an EPD for all these products, right? A real one from a manufacturer, you can guess which one, right? We reviewed three types of cladding systems with these parameters. So we took the Z-girt one, which I showed you guys earlier. You know, those are vertical, horizontal Z-girts. We took a clip and rail system, and we were saying that so the Z-girts are at 50% effectiveness. Clip and rail is at 75% effectiveness. And then direct fastening is at 95% effectiveness. We took a wall type where we wanted to achieve effective R23 in the wall. So we used R20 cavity insulation, which typically gives you about an R11-ish, R12, depending on the stud spacing. And then whatever amount of exterior insulation that we needed in order to get to that R23 effective wall value. And the measurement took into A1 to C4, which, who remembers what that means? A1 to C4. Cradle to grave. Cradle to grave. Okay? So that's what we did. And I have multiple slides on this, but I'm not going to go through them too heavily, but I'll give you the results of this. So if you wanted the thinnest wall, and this is just, again, based on the insulation, not on the components, because you could argue right away, if you have metal strapping, that's going to add embodied carbon right away, because we know metal does that. So just taking into consideration the insulation pieces, this would be the thinnest wall that you could possibly create, but you can see it's kind of got a pretty high carbon level compared to, say, the wall with mineral wool and fiberglass, which is around 8.75 kilograms of emissions per metric square, so, or meter squared. So you can see these are kind of the results that we got from doing that. And you could, at first we think from an effectiveness perspective, direct fastening was the most effectiveness, so we would get the best performance, but it doesn't always mean we're getting the best performance when it comes to, say, the environmental side. So we can see with the clips, we seem to get a little bit better environmental performance out of that while still maintaining the performance that we need for the wall. And then, like I mentioned before, there's carbon sequestering insulations, and these are a couple different ones that are available, from hemp fiber all the way to straw bale. Straw bale is one that's coming out, but again, I don't believe all these installations have a product category rules set up, so that once that gets set up, then we can really make sure they're all being evaluated in a correct manner. Now, when it comes to carbon payback period, and this is something that people look at a lot, they're like, okay, if I use this installation, how fast am I going to get my ROI on the carbon? And a study was done by NAMA, which is the North American Insulation Manufacturers Association. They hired a consultant to determine where the carbon payback was, and they said if the wall is under 2 kilograms, so typically your standard residential construction, baseline construction would be around that the embodied carbon would be recovered in the home within 1 year, right? When it comes to commercial, and those are standard wall assemblies with mineral wool and fiberglass in there. You can see that was at an 8 kilogram. This is, if it's 10 kilograms or less, you're going to be able to recover in a year. So if you use foam, and people think, oh, I'm going to use foam, it's going to add 3-4 years to my carbon payback, turns out it's only a few extra months depending on the type of foam that you're using, right? So it's all about what you want to select for that. Now again, these are the resources that I was mentioning before. So City of Nelson's Material Carbon Emissions Guide, check that out. Carbon payback analysis done by ICF, or is that what they, yeah, it was done by ICF. And then there's low carbon solutions. BC is really ahead of the game when it comes to this. BC Housing has done a lot of these, and CLF in BC is also have a low carbon material sourcing guide too. So these are a lot of different options to find resources, third-party resources for that. But if you're looking for specific manufacturer ones, like for example, Owens Corning, they have a technical library, and they're able to provide environmental product declarations as well, and then they have some other sustainability information. Now I'm going to pass it back to Stephanie.
Okay, so now I'm gonna focus on some design considerations specifically focused on facade materials. So related to conducting a life cycle assessment, it's really important that your facade materials have a design service life of at least 25 to 50 years. That is not related to the warranty. That's related to like a calculation of how long and the maintenance frequency that a material will require. And so I'm going to start to focus on the different individual buckets from the common materials framework. So the first one, the ecosystem health, that one's focused on preferring products that support and regenerate natural air, water, and the biological cycles through life with supply chain management focus. So here is a website I recommend using. It updates anytime, so you can kind of type in wherever you are, and it will show you the carbon intensity at that specific time. So it's kind of alarming at like just looking at the grid and just also knowing that sometimes from an embodied carbon perspective, it actually makes more sense to import a material from a location in which the grid is green, so any of the green locations, or a clean grid, I should say, and the A4 to A5, which is the transportation embodied carbon, isn't that much with transportation. It's really like the manufacturing and the extraction of the material that have the hugest impact on your ability to decarbonize a material. And so here are some helpful steps when you want to prioritize that specific category. Is always ask your manufacturer for third-party verified environmental product declarations. If they have any bio-based materials in their product, ask for like third-party certificates like a cradle to cradle. If there's wood in it, forestry, like a FSC certificate. Pretty much always anything third-party verified. That's really going to help you with the greenwashing. From a social health and equity perspective, that means preferring products and from manufacturers that secure human rights in their operations and supply chain of the material. And so these are the 12 problematic materials that have been identified. So a lot of these also are materials that get used on projects. And so for me, it was really alarming that like some of the minerals that are pretty much used in everything are one of the problematic materials. Something else that's coming up also is like the synthetic and artificial ingredients that get added. What is the impact of like from the extracting, like how toxic is it to that individual community? Also like the end of life, how is it being disposed of? And so if you're really interested in that, there's a lot of helpful user guides as well as a master specification you can use, procurement guides from like an owner, designer, manufacturer's perspective on design for freedom. They constantly publish helpful guides. They have a office hour where you can ask them any questions that you have. And then circular economy is the focus of reusing and improving the supply chain by putting back in materials into that manufacturing process. And one helpful resource for that would be like the Ellen MacArthur Foundation. They have free education courses where you want to learn a little bit more about circular economy as it relates to building materials. They also have information on if you're conducting a whole life cycle assessment and you want to look at the D category, which is the end of life, that isn't commonly done on projects. They have a lot of helpful information on like what are design considerations, what are structural life safety considerations for regrading different structural materials to be able to reuse it in a different building application. And then also the government of Luxembourg has product circularity data sheets, which are starting to feed into the EU's move towards material passport. Personally, I think that is going to be the future within like a global marketplace. Climate health, I think you're very familiar with that. That's the focus on decarbonization of materials. So the future is going to be moving towards low carbon as well as biogenic based materials. Materials that are able to have individual components that can be broken out and put back into the supply chain. There's a lot of work being done at different levels across Canada as it relates to that. And so a helpful guide for that, I would recommend the Carbon Leadership Forum. They have a lot of information about that. And from human health, that's really focused on prioritizing materials that are not detrimental to human life as it relates from manufacturing, the installers. I think that is a group of individuals that often their rights don't really get looked at, of like how safe are our construction sites, how safe is it to install a lot of these materials. Despite something saying it's low VOC doesn't mean it doesn't have carcinogens in it that you just can't readily detect. This is becoming like really like mainstream right now with PFAS. So it's like those forever chemicals that are in pretty much everything. And so luckily there's a lot of information that's coming out there now from like even a personal consumer perspective. There's a lot of helpful resources through like the Parsons School of Design. Cradle to Cradle is another great resource, and the Living Futures Institute. And then for those that are interested in specifications, the way to really hit all your goals on this is performance-based. Really let the contractor or let the industry figure out how best to achieve that. So specifically for embodied carbon, we typically do either a carbon budget, so all the steel has to have a maximum global warming potential where we factor in reduction into that number. But for more complex components like the building envelope, we'll set a minimum baseline of like this is the maximum global warming potential we'll accept based off of this industry A1 to A3 evaluation. So I will pass it off to Andrew to finish off one of the slides.
Yes, this is my favorite slide. I'm very, very excited about this because this is potentially the future. We've talked a lot, and something that's been coming up now about modular building and doing stuff offsite and then bringing stuff on. So this particular project right here was done in Eindhoven, Netherlands. So it was submitted as for Dutch Design Week, and this particular project, which is super neat, was all done prefab. Everything was cut so that they didn't waste anything. Everything was brought to site. They set the whole building up, and then once Dutch Design Week was done, they pulled everything down piece by piece and then brought it back to the owner. So no waste at all. And with one particular exception. So if you look on the left, I guess it would be your right. The right side screen, you see this facade, right? And with this particular facade, they made this with the waste products of the city, and they made all these tiles, they set them all up, and then when they're done, they gave the tiles back to the residents, right? Kind of as a souvenir for this particular project. And this project won a ton of different awards. Let's see. It's called the People's Pavilion. It won Frame Awards in the category of Sustainable Design, the Dutch Design Awards in the category of Habitat, ARC 18 Innovation Award as well. So very fantastic product, but this is kind of a glimpse into potentially where the future is going to go, where we'll be able to deconstruct buildings and move them and take those components and reuse them in other areas.
And then to give a Canadian example that you can start to achieve some of these high sustainability metrics would be Canada's first Living Building Challenge. This was back probably 13 years ago, where mass timber was pretty early in its days, so the majority of the building is designed and built to be disassembled. Everything was sourced within like 100 kilometers of that site. That was very difficult for me to source that in the middle of the forest in nowhere in Ontario. It was eye-opening for me at that time because even wood, and it's still an issue, wood is not entirely ethically grown and sourced across Canada. That was really alarming for me to find out. We had to get all the wood on this project from Quebec, from one manufacturer of mass timber that actually had their own forest, so they were able to control the entire supply chain, report on biogenic carbon in an accurate way. And then some interesting features about this is the cladding on that is wood that we diverted from waste. It was like 100-year-old historic wood that we just regraded and did mechanical fastenings. That way, if something needed to be replaced or the building needed to be disassembled, everything could come apart. The only thing that wasn't designed for disassembly was the stacked masonry that we had on the project. But for the most part, this project had minimal materials because everything had to be extracted and installed within like 100 kilometers of that project site. And so some closing thoughts is your building ethically sourced and sustainably
designed? Sorry, I got
Yeah.
excited.
Okay, so hopefully we have some time for questions. Okay.
Who's got some burning questions that they're excited about? Good stuff. We were so thorough. I know it's like drinking through a fire hose.
Concern with all this is the cost, right? Because you can't adopt what's coming through without, like, the increased cost, right? So you've got this two sides battling each other, which, I don't know, what is like Owen Scorn, what is their position with that? Because you look at some of these new products, right?
Yeah.
And per square foot, it's substantially more expensive.
Yeah, and this is something I've definitely had some in-depth conversations when it comes to the affordability piece, right? Because we have a lot of great ideas and there's a lot of great products. There's even products that Owens Corning doesn't make that are fantastic, but it's like, how much does it cost to have this solution, right? So it's finding that middle ground in between from an affordability standpoint. And that's why I had a couple different ideas out there when it came to wall assemblies. Like, for example, instead of using mineral wool in the cavity, use fiberglass. And if you're interested about that, if you go to our website, we have a calculator that can show not only a cost savings, but then a little bit of an embodied carbon piece from a transportation. But like Stephanie said, transportation's the smallest part of that. It's more the manufacturing piece. But those are areas where you start making small choices right there that can help you affordability, but still maintain the performance, right? But that's why it's important to evaluate all the products that you're using in your walls, right?
Yeah, and maybe just to like address the affordability, I just happened to have been at an event yesterday with Parliament where a lot of like the Canadian leaders in sustainability, we really emphasize for them that they really need to put funding to manufacturers here in Canada to start to bring down the cost premiums. Like Andrew mentioned, like an EPD is like $30,000. That limits the ability from like a small industry up and coming manufacturer that wants to get into the marketplace and to compete. So we've made recommendations on like providing like different financial plans or different backing, because like in the US pre the election, there was like a couple $2 billion that they pumped into manufacturers in the US to bring them all up that they could sell their products at the global level. Because like in the EU, all of what we presented, that's the only way you can sell products like in other marketplaces.
And one more thing about the affordability piece, it's kind of one of the things that's also driving why we haven't been able to evolve from a higher tier, and that's one of the reasons why we're not adopting, like, we're probably going to adopt a piece of the code, not the whole code, because there's always this question about affordability. You know, why do we move from tier 1 to tier 2? I don't know if you guys know, building code is tier 1 all the way to tier 5 would be technically net zero. So it's why we get nervous about going up, because that affordability conversation. But the reality is that if a lot of builders or even commercial designers look at it, there's probably some tiny tweaks that they can make that actually put them into those levels without being significantly expensive, right? Increasing your air tightness slightly. That's not usually, tends to be not as a big expense, but can do significant, it can increase the performance significantly.
Yeah, very good presentation. I like your life cycle assessment and carbon neutral. You did mention about human health. You didn't get too much into indoor air quality because people occupy the indoor environment. Can you say something about that? How you would address it?
Yeah, so there's different, like, there's the low emitting, which focuses on like formaldehyde and like forever chemicals that are in there. So one ask of manufacturers is, do they have a certificate from like the California Department of Public Health? The interesting thing about that is there's a version for schools and there's a version for offices, and you would think that for schools it was more restrictive. No, it's actually more restrictive for offices.
Why is that?
Yeah. So that's like an interesting tidbit, but there's a lot of work being done on like indoor air quality, even like the abrasion considerations of materials as the particles come off of it. Like, how do you track that? How do you track that through the life of a project? So that's where like some of the indoor air quality testing and enhancement options through like the well building would be something that we would recommend to look into, but always like third party verified.
Green Guard Gold, those kind of.
Yeah, Green Guard Gold would be another one for like different materials or like a certification body.
Any last thoughts? No? All right, well, we've hit our time. It is now 3:30, so a nice round of applause for Stephanie and Andrew for joining us today. And thanks again, and enjoy the rest of Buildex Alberta.